Another day, another integral. Let me start the timer right away. Alright, today we're going to take a look at the inverse sine function of x. To integrate the inverse sine function of x, we're going to take advantage of the integration by parts. But to do this, we need to know the derivative of the inverse sine function. In our case, the inverse sine function f of x is equal to the inverse sine function of x. The derivative of the inverse sine function is just 1 over the square root of 1 minus x squared. Okay, if you want me to explain why this is the derivative of the function, let me know in the comments and I'm going to explain it. So next we're going to take a dg and let it be equal to dx. At the same time, we need to integrate this, so we get g of x is equal to x dx. Okay, now we're almost done. We just need to plug in, which means we have f times g minus the integral of g times df. So we have x times the inverse sine function minus the integral of x times the derivative of the inverse sine function. Dx. Okay, now we're going to do a little substitution. We let u be equal to 1 minus x squared, and thus du will be equal to negative 2x. Okay, let's plug it in. We have x times the inverse sine function of x. Minus and minus give us a plus here. The integral of, and now we have a 2 here. We have a 2 from this, so we need to correct this by putting in a 1 over 2 in the front, which gives us 1 over the square root of u, du. Okay, now we just need to integrate this little integral with the half in front. That the integral of 1 over the square root of u is 2 times the square root of u. And the 2 and the half will eventually cancel out. So we have the inverse sine function of x plus 1/2 times 2 times the square root of u. Now we're just going to do a little resubstitution, which gives us x times the inverse sine function of x plus the square root of 1 minus x squared. And let me put a plus c at the end for the first time in the entire series, because I forgot it every time before. Alright, so we're only 3 minutes in. That is not enough. Click. Alright, next we're going to take a look at the inverse cosine function. We take the same approach. First we write down f of x is equal to the inverse cosine of x, and we let df be equal to the derivative of the inverse cosine function is basically the same as the derivative of the inverse sine function, but it has a minus in front. dg, we let that be equal to dx, and g of x will then be x times dx. 1 second. Okay, excuse me. Okay, so we're going to plug this in. F times g minus the integral of g df. So we have x times the inverse cosine of x minus the integral of x times, let me put that minus in the front and make this a plus, 1 over the square root of 1 minus x squared dx. And we're going to do our same substitution again. We let u be equal to 1 minus x squared, and du is then minus 2x. Okay, let's plug it in. and we get x times the inverse cosine of x, plus and minus give us a minus here, the integral of, and we put the 1/2 in the front again, 1 over the square root of u du. Okay, almost done. The integral of 1 over the square root of u still hasn't changed since we started the video, so we have x times the inverse cosine of x minus 1/2 times 2 times the square root of u. We do our resubstitution and we get x times the inverse cosine function of x minus the square root of 1 minus x squared plus c. Alright. So we're only 6 minutes into the video and that's still not enough. So, boom. We're also going to take a look at the inverse tangents. Okay, the inverse tangents, we basically take the same approach again, but the derivative is a little different, which changes things up a little bit. So, we let f of x be equal to the inverse tangents of x, and the derivative, the f of the inverse tangents, is 1 over x squared plus 1. We let dg be equal to dx again, and g of x will then be equal to x dx. Okay. Plug it in, which means we have x times the inverse tangents of x minus the integral of x times 1 over x squared plus 1 dx. Now we're gonna let u be equal to x squared plus 1, which means our du will be equal to 2x. Okay, we have x times the inverse tangents of x minus, and we need to pull a half in the front again, so we have 1/2 times the integral of 1 over u du. The integral of 1 over u is just the natural log of u, so we have x times the inverse tangents of x minus 1/2 times the natural log of u, and now finally we do our u substitution and we have x times the inverse tangents of x minus 1/2 times the natural log of x squared plus 1, and finally plus c. Alright, and stop the timer. Okay, so these are the 3 inverse trigonometric functions. Next time we're probably going to take a look at a little fancier things we can do with this, but these are the basics. Thanks for watching.